10 meters requires high sunspots, and it pretty much is daytime only. It'll go into the night a little bit, but it's pretty much daytime only. When 10 meters is working, it's the best of the best of the best. Does anybody work 10 meters when it's hot?
Years ago.
Tell me your experiences with it.
They're signal.
Loud, low power.
The Australia and New Zealand come in hot.
Is that something anybody else?
Yeah, worldwide, and then also the sporadic E-clouds that you can get on and works, and you can follow the cloud as you hear the stations that are coming in on this sporadic E-cloud sometimes.
Exactly.
Did it about 2 years ago at a neighbor's house. I think this was like during springtime, and it was local for like 2 hours, and then all of a sudden, just like that, it shut off. But we were able to make a contact on this one country that he needed that because he hasn't worked that country, but I worked it before he did, but he actually did, and it was just fantastic.
Great, Chad?
I was gonna say, back when I got my novice in the late 80s, on a Swan 350 and a P-6 dipole built out of scrap wire and PVC pipe. You got up in the morning, you were guaranteed to get Europe, and if you stayed around in the evening, you were guaranteed to get to Canada, Australia, clear as day. It didn't take much power or effort.
For sure, for sure. Go ahead.
Question, what is the expected ground load on
Don't know. Don't know. Well, you bring up a point that's really interesting. You talked about you wanted to work the country and your buddy wanted to work the country. I'll tell you something that surely many of you have heard, but some of you have not. If you're working a rare country, be sure and work them first before you tell your friends about it.
We were in the same room, and he was doing something else. He said, "Oh, I need this one." Says, "You go ahead and do it." And so I did. I made the contact, and then he got on, and it took him a little while because of Paula, but he finally got the guy. So, but we were in the same room, so it worked out great.
Don't tell your friends, don't spot anything until you work. Back up. Anyway, great DX, very loud signals, with halfway around the world, and very low power required. Sporadic E is very common, May through August. And I don't know if you guys are planning on doing 6 meters on field day, but should be good this year. If anybody's got 6 meter antennas and stuff, it should be good to try it. Okay, next we're going to talk about the maximum usable frequency. Now, out on the internet, there are just tons of programs out there to help you calculate things. There's modeling software to help you analyze things and stuff like that. That's kind of what I'm trying to convey to you here, and I'm going to show you some of these programs in a little bit. But this is kind of like Chad. I've been helping Chad kind of get active in HF again. And there's a program out there called DCARC Suite. It is the best software, bar none, for log keeping, spot collecting, propagation, prediction, digital communication, stuff like that, because it's all tied together. And one of the reasons it's best is it's free. I used to have Logic 8. I paid $130 for it. That's good. It's now, they got a new version out, Logic 9, about the same price. DCARC Suite, I'm not trying to sell it because the guy won't give me any commission because he doesn't charge anything for it. But the reason it's best is it's all tied together. But it is, and it's not beautiful software like ham-rated deluxe, or perhaps even logic. But it is so dang effective. It's unbelievable. You can see all of the DX you worked and all the DX you need to work. Your spots that you haven't worked just pop right up. You can just be sitting there working your radio, and all of a sudden a spot will pop up in red, and just click on it, turns your radio, turn your antenna, turn your rotator, and it won't work. He's working on that. He's working on that part. I think that's the one thing he's going to charge for if he ever gets that working. But it's just fabulous software, and the reason I even bring that up is because when Chad put it, it's complicated. I mean, it looks like it's horrendously, looks like it's horrendously complicated. It is right until you understand what you need to do to get it going. There's just a few basic things you need to do to make it work, but it just looks really, really complex. Well, same thing true with HF, same thing true with propagation, same thing true with these software programs. You can go out and look at modeling and propagation and use maximum usable frequencies and stuff like that. There's so much out there you don't know where to begin, but just start with the basics. Just get a little thing. First, I'm going to show you some basic stuff in a little bit. It'll help you get into it, but don't be overwhelmed by it. Just start looking at stuff to figure it out. Sunspot numbers, as we brought up a few minutes ago, that's the first thing people typically start looking at is where the sunspot numbers. And we'll talk about that more, and that's something you want to know. Another thing you want to know, and again, we're going to talk about this in a minute, is if we have a coronal mass eruption, what that means is the sun ejected some serious plasma out there, and the effects of it are coming to Earth, and it shuts down communication. And you can get all excited with your radio and your antenna and all prepared and go, run home after work and hook everything up. And if there's no propagation, it's a waste of time because it's not going anywhere. You got to have propagation to get any DX. So anyway, maximum usable frequency is one of the little programs you can look out there that will predict for you where you can go on what frequency, the maximum usable frequency on this band that I can perhaps get to this guy. Gives you, it's a function of the path, the time of day, the season, the solar, UV, X-ray radiation levels, and atmospheric disturbances, and I'm going to be talking about that a little more. The lowest usable frequency is just the antithesis, that's the bottom. The effects of the sun. The sun dramatically affects all of the long-distance communication, all the propagation we do in ham radio. Sunspots certainly affect it. Solar flux dramatically affects it.
Solar flux.
Well, I'll be talking about that in a minute. Solar flares really affect it. Geomagnetic storms that I was just alluding to, coronal mass ejection, they call them CMEs. I don't pretend to understand this stuff totally, but I can tell you one of the sun, what is it, 93 million miles from here, the light gets here in 8 minutes, radio waves get here in about 8 minutes too, right? Well, one of these, and I can't remember which one it is, one of them takes 3 days before it gets here. And I don't understand or don't know why, but perhaps somebody else does. But the other one happens really quickly. So, and then we'll be talking about the A and K index. Here's a software program that rather than wait till Matt gets us up on the website, you probably want to write this down. This is a good software. There's a couple of them here you want to look at. If you're interested in kind of getting a feel for propagation, this is kind of like DX Lab Suite and Chad. You look at this thing and say, oh my gosh, where do you start? There's so much out there. Well, this is one of those, this is kind of like I used to refer to, when I got into a computer program, I didn't know much about it, but I'd go take the manual in the bathroom with me every once in a while and just see So this is kind of like that thing, when you got some time, just sit down and start looking over and playing with it. Don't play with it to try and, say, I want to learn it, just play with it, see what's going on out there. Click on this thing and see what's going on. This is a good website to start looking at stuff. There's 2 or 3 guys out there that have some really good websites on solar productivity. Go ahead.
This program is real time.
Some of them are, some of them aren't. Some
But
of
this
them,
program is real time. Solar hand is.
well, some of the stuff on there is real time, some of it's not. That's what I meant to say. Some of the stuff's on there is real time, some of it's not. There's a lot of really cool pictures out there too. Go ahead.
Yeah, no, if I might explain, a lot of these observations are time averaged observations made by various solar radiation laboratories in North America or other parts of the world for that matter. So they can't be real time as such.
Right. Some of the collection points, they've got one up in British Columbia, they've got one down in the Caribbean, they've got them all over the United States. But this is a really cool site. It's really neat. Here's